Okay, let's start by finding the distance from B to E here. And to do that, I'm going to, I realise that this triangle here, this triangle BEC, is in fact a right-angled triangle. Just make that a bit narrower. Is in fact a right-angled triangle where that's 100, that's E, and that's B, and that's C, and this is 30 degrees. So I can just use trigonometry here. This is the opposite. I want the length of BE, which is the hypotenuse, so I'm going to use sine, and sine 30 is equal to the opposite, 100, divided by the hypotenuse, which is BE. Now to rearrange that, I'm going to multiply both sides by BE. So BE sine 30 is equal to 100, which means that BE is going to equal 100 divided by sine 30. And if I work that out, it comes out as 200 meters. So BE, I'll stick it on the diagram here, that length there is 200. Next bit here asks me to find the angle that path AE, well here's path AE, makes with the horizontal. And to find that angle, I drop a perpendicular down vertically, okay, and the triangle that I'm going to make is this one. So the angle that BE makes with the vertical, makes with the horizontal, is actually this angle here. Let's call it theta. So I need to work with this triangle, triangle AEC. Now I know EC is 100, so what I need to do is actually find either AC. Now if I look at AC, I realise that the base here is a rectangle, and although I know AB is 500, I don't know BC. I suppose I could work it out, but it would be easier for me to work out this distance, AE, because I know the distance from F to E, that's 500. I know now that this is 200. So if I just draw that rectangle from above, so I've got F, E, and then B, A. So I can find the distance from A to E using the fact that BE is 200 that I've just found, and AB is 500. So AE then is going to be the square root of 200 squared plus 500 squared, and that comes out as the square root of 290,000. So AE is the square root of 290,000. And from the calculator, that's 538.5. I'm going to save that in my calculator memory and call it A. Okay, so I'm now going to find theta because I've now got two lengths in the triangle that I'm needing. So there's A, there's E, there's the theta that I want. This is C. I know that that's 100, and I know that AE is 538.5, blah, blah, blah. So again, I'm going to use trigonometry. This is the opposite. This is the hypotenuse. So sine theta is going to equal 100 divided by 538.5, which I've saved in my memory as A. And that gives me an angle of theta. Once I've done sine minus or inverse sine of this value, it gives me 10.7016 to there. So theta is 10.7 degrees to 1 decimal place. Okay, part 3 here says to work out the area of triangle ABE. And actually, if I go back to this rectangle, the area of triangle ABE is just half the area of this rectangle. So the area of triangle ABE is actually just 500 times 200, and that's divided by 2. Well, actually, that just becomes 500 times 100, which is 50,000. So the area of triangle ABE is 50,000 square meters. Now, it now says, hence find the length of BG. Right, well, if I look at BG, okay, if I just put it into this triangle here, there is G, so that the angle between BG and AE is 90 degrees. Now, I've got an alternative way then of finding the area of triangle ABE. If I take AE to be the base of the triangle, so I'm talking about this triangle here, the base is AE, and the height is BG, because remember, for the formula for the area of a triangle, the base and the height must be perpendicular to each other. So essentially, AE, which I've worked out earlier as the 538.5, so that's AE. If I multiply that by BG, well, that's the length I'm trying to find, and I then divide that by 2, it will give me the area that I have just found for triangle ABE, which is 50,000. So if I rearrange that to find BG, BG is going to be 50,000 multiplied by 2, so let's just get rid of that, so this is, get rid of that from there, multiplied by 2, divided by 538.5, blah, blah, blah. And if you work that out, it comes out as 185.69, which to three significant figures is 186 meters. So BG